So velocity and speed. Velocity is a scalar quantity, speed is a scalar quantity, velocity is a vector quantity. Scalar has only magnitude, but vector has a magnitude and direction. So you can take that example when car is moving with a speed of 40 kilometers. So it has no difference for the velocity and speed. So magnitude, you can define that magnitude 40 kilometers, 50 kilometers. But velocity has the magnitude and the direction. So see that now car is moving in the path. So magnitude of the path of the length, see that. So magnitude of the path, when it comes to the initial final position, that is the displacement. The distance between the initial and the final position is called the displacement. Okay, it has the direction because the car is changes in the direction. Average velocity. Average velocity means depending on the time period, the velocity is constant. Or you can take that as a regular value. So you can draw the graph between the displacement and the time. See that x and t. So it's the average velocity. How to calculate the average velocity? So this is the graph between the distance and the time. So how to take the average velocity? We can divide that into equal 5 seconds. You can draw that line like this. You can select the 2 points A and B. So you can draw the tangent line. That means it's a straight line. It's anchored to that between the point A and B. So for x1 position, x2 or the other position, the time period you can calculate in the x-axis. That is 3 seconds T1, 7 seconds T2. The distance between the displacement between the 2 points is x2 minus x1. That is change in displacement. Change in distance, that will give the displacement. Change in time period, delta t, T2 minus T1. So we can calculate the velocity. Velocity equal to, you know the formula, rate of change of displacement. That is delta x by delta t. Change in distance. Delta means change, a small change. Change in distance divided by change in time period, delta t. Velocity v. Average velocity means that is arrow bar, that is bar is indicating that average velocity equal to delta x by delta t. The SI unit of velocity is meter per second. Meter is the unit of length and s is the time period of the second. So we are indicating that velocity by kilometer per hour. So you can take the difference in the distance and the time period. So we can calculate the average velocity and average speed by using the point A and B. You can calculate the delta x equal to change in distance x2 minus x1. Delta t equal to the same time 42 minus 10. So that is in the graph. So 32 is the change in distance. Time period in that particular distance. T2 minus T1. So from 7 minus 3 you can get 4. So we can divide the two values. By using this formula 32 by 4 you can get average velocity equal to 8 meters per second. This is the method of calculating the average velocity by using the graph. So that AB line indicating that average velocity. So slope you can calculate that tan theta. Theta equal to opposite side by adjacent side, that is x2 minus x1 divided by t2 minus t1. So this is the delta x by delta t. That is change in distance by change in time period. See that how that line is going. It's not a straight line, it's a curved path. That's why we are taking the average line, the straight line. Approximately we can draw that line. So the time period between the T1 and T2, that is 3 to 7. So 3, 4, 5, 6, 7. For each time period, you can calculate the distance in that graph. See that y-axis indicating the displacement, corresponding time period of the x-axis. So for 3, you can calculate the displacement. 4, 5, 6, everything you can calculate the displacement. Right? So depending on the time period, when time changes, distance also changes. So again, you can see that the car is moving in a straight line, but it is not a average velocity. See that it is traveling in the 3 different time periods and the 3 different velocities. Okay, T1, T2, T3 are the 3 time periods. Velocities are V1, V2, V3 are the 3 different velocities. So average velocity you can calculate that average all the velocities divided by 3. So you can calculate the average velocity. So you are traveling from your home to workplace. So you can consider that a car is moving from your home to workplace. The distance traveled by the car can consider that you can take the distance traveled by the car from home to that workplace. It may be a straight line and a curved path, but reference we are going to take only the straight line. So it is in the positive direction. So positive x-axis. So when you draw the graph between the time period and the distance, you can get the straight line because it is a uniform velocity. You see that gradually it increases the distance according to the time period. That angle is theta with that x-axis. So using that, you can calculate the velocity. So by finding the theta value, you can draw the slope. In that slope, we can calculate the average velocity. Right? So see that the car is in the rest position. That means it's moving in a constant velocity. Then it is moving from workplace to home. So home learn the workplace to then it is returned back from workplace to home. That is negative direction. Suppose you are taking the x-axis, it's a negative direction. See the slope is slowing in the downward direction. So it's called a negative direction. So using that, you can calculate the displacement for the time period of particular time period. And initial and final position is the total time period. So car is moving in a curved path. The magnitude of the path of the length is actually traveled by the object, that car. So displacement is the initial and the final position. Distance between the initial and the final position. But distance of the car is the distance between the initial and the final position. That is equal to 0 because if that car comes to that, again it is a previous position. So the distance becomes 0, but it has a displacement. It's traveled from here to that whole distance, actual path. It has a distance, but displacement becomes 0. Now you can see that car traveling from home to workplace, the velocity is not a constant. See that 15 kilometers. That is a 15 kilometer distance, traveling with a velocity of 15 kilometers per hour. So the speedometer causes a 15 kilometers per hour reading throughout the journey. That means what? Car traveling in the constant velocity. See that? But it is not actually constant. See that needle is moving in the upward and downward direction. It's not a constant. So in traffic, it comes to 0. It increases 5, 10, 20 like that. It's not a constant. See that it will vary. Suppose nobody is there on the road, it will move with the constant velocity of 50 kilometers. So it is a varying that magnitude of the velocity. So the speed is indicating only the magnitude. But velocity is indicating the direction also. So it is not a constant. It's a varying depending on the time period. So we can calculate the instantaneous velocity. Instantaneous means delta t tends to 0. What is that means? It's an infinitive. For the very small time period, delta x by delta t, or velocity equal to rate of change of displacement dx by dt, or change in displacement by change in time period. So using that, you can calculate at any instant of time what is the velocity of at the 5 seconds or 10 seconds or 15 seconds. You can calculate that by using this integration. So time period changes the position for T1 and T2. So these are all the two time periods, initial and final position. So the car is traveling like this. See that the distance is increases for the time period reduces. That means it is accelerated. The velocity is increases. So using that, we can calculate that x equal to f of t. That is a function. Here will be indicated by d equal to dx by x. So this is the function of f of t. So we get in the graph x t graph. X represents t is the time period. So you can see that position t. You can take one point, that point is t. So in that particular time period, t1 and t2. P1 and P2 are the other two positions. You can line drawing the point P1 and P2. We can get the average value by delta x